Okay, good day, good people. Let us look at reduction formulas. We are continuing with our trigonometry. We are still reminding you of things that you should be knowing, and we will be doing the application. Let's look at your reduction formula. Right. Now, the reduction formula reduction formula are used to convert. Okay, I used to convert trigonometric functions of the expression 180 minus theta. Okay, or 180 degrees plus theta and 360 degrees minus theta. Now, reduction formulas are used to convert trigonometric function of the expression 180 degree minus theta, 180 degree plus theta, and 362, okay, to a trigonometrical functions of theta with an with theta acute angle. Okay, we'll explain to you now in simple terms. Now, reduction formulas, good people, it is nothing but reducing obtuse angles to acute angles. Now, obtuse angles, we know that it is angles 90 to 180 degrees. Then acute angles, it is angle 0 to 90 degrees. Now, in short, we are reducing obtuse to being acute angle. That's what we will be dealing with under your reduction formula. Now, what is it that we know from the cast? We know that on your first quad, it is 0 degrees to 90, or it is 0 degrees to 90, or it is 90 minus. Then we know that on your first quad, already the angles that are in acute. All the angles on your first quad, they are acute and they are positive. That's what we said, isn't it? All signs are positive on the first quad. Now, on the second quad, this is what we have on the second quad. Remember, we are dealing with those expression 180 minus. Now, when you look at, oh, my handwriting, good people, it's even horrible on your, really now, let's try to write. Right, hopefully you are able to see. Sorry about it, I still have to master how to write properly there. Now, on the second quad, let's say we are having our resultant somewhere there. This is our resultant. Right. We said it that on the second quad, it will be 90 plus or 180 minus. Now, check this. We are having on the second quad the angle from 0 to the second quad, it is 180. The angle from 2, it is 180 degrees minus, because that's what we said here. We said we used to convert trigonometric function of the expression 180 minus, 180 plus, and 106 to a trigonometrical function of this theta, with theta an acute angle, meaning this theta being from 0 to 90 degrees, being an acute angle. Now, on your second quad, this is exactly what we have here. 180 minus. We know that it is 0, 90. This side, it is 180. Now, we are having 180 minus. The theta here, it is this angle, and it is acute angle. Okay, now it means this is the angle that we have to use and work with, because we are reducing obtuse to acute angle. Now on the second quad, we are having 180 minus, and this is the angle that we will be using. Now if it is sine, we know that the angle here, it is what? It is positive if we are dealing with that trigonometrical function there. Then the rest, they are negative. For instance, if we are given sine 180 degrees minus, it will be 180 degrees minus of the angle there. Then we know that our angle there, it has to be positive. It is sine theta. It has to be positive. But if we are dealing with the trigonometrical function cos, we are having cos 180 degrees. It will be minus theta. But we know that the angle here, cos here, it is what? It is negative. It means here we are having negative cos theta. If we are dealing with tan, it will be tan 180 degrees minus theta. Then we know that the tan there, it is negative. Then it will be negative tan theta. Why? Because only sine, it is positive on the second quad. Okay. But on the first quad, all signs, they are what? They are positive. Now let's look at the third quad. Let's look at the third quad. On the third quad, we are having 180 plus theta. We are having this expression 180 plus. Okay, meaning if we are having the resultant, it means it will be 090 180 180 plus, but we want that angle. But that angle, it has to be small, it has to be acute. Now hence we are having 180 plus. But what is it that we know about the third quad? We know that tan, it is positive. It means this side we are having sine, open bracket, 180 plus theta. But we know that sine on the third quad, it is negative. It means it will be negative sine theta. If we are looking at cos, it will be cos 180 plus. Then we know that cos, it has to be negative. It will be negative cos theta. Then tan, when coming to tan, it is 180 plus. Then it will be positive. It will be positive tan theta. The angle on the third quad would be positive. Okay, because we are dealing with 180 plus. Okay, then on the third quad, we know, on the third quad, we said it that only cos is positive. On the third quad, only cos, it is what? It is positive. We are having the resultant. It will be 0, 90, 180, 270, 360. But now on the third quad, we are having this expression, 360 degrees minus theta. But this angle, it has to be acute angle. Okay, this angle, it has to be from 0 to 90 degrees. It means if we are dealing with sine here, sine, it will be sine 360 degrees minus. Then we know that sine, it has to be negative. Then we are going to have negative sine theta. If it is cos, we know that cos 360 degrees minus theta, cos here would be positive. It will be positive. Cos here would be positive. If it is tan, it will be 360 minus theta. We know that it will be minus tan theta. The angle there, it has to be negative if we are looking at tan, if that's what we are given there. Now, the whole idea of your reduction, even the term itself, it explains itself. You are reducing. Now, on reduction, you are simply reducing. We use the reduction formula to reduce trigonometric ratios to an acute angle. That's what we are doing under your reduction. We use the reduction formula, okay, to reduce trigonometric ratios, trigonometric ratios, your sine, cos, tan, to an acute angle. That's what we are doing under your reduction formulas. The quadrant determines whether it is positive or negative as indicated. Now, the quadrants, they will then indicate for us if that acute angle, it is positive or negative. That's all the quadrants will indicate for us. First quadrant, second quadrant, third quadrant, and the fourth quadrant. They are simply indicating if this angle is or negative. But the reduction, we are reducing obtuse to acute angle. Okay, another thing that I want us to look at, it is your negative, the positive angles. I want us to look at that so that we can be able to do and apply that which we are supposed to be knowing in solving the trigonometrical sums, now, we are having 0 degrees, 90 degrees, 180, 270, then it is 360 degrees. Now, we know that when we are rotating anti-clockwise, all angles, they are what? They are positive. But when we rotate clockwise, all angles, they are what? They are negative. All angles, they are negative. But when we rotate clock or anti-clockwise, all the angles, they are what? They are positive. You are even 0, 10, 20, 30, 40, they are all positive if we are rotating anti-clockwise. 10, 20, 50, 90, no, 100, 120, 180, they are all positive when we are rotating clockwise. No, 190, 200, 270, they are all positive when we are rotating what? Clockwise. Then when we are rotating anti-clockwise, they are all positive. But now, when we are rotating clockwise, 0, negative 360, 270, boom, 0, 360. You can as well say 0, 10, 20, 30, 40, 50, 60, 70, 80, 360. They are all negative. And we call this coterminal principle. Coterminal principle, okay? Now, let's explain the coterminal principle a bit, whether we are rotating clockwise or anti-clockwise. Now, all signs here on the first quad, they are positive. The opposite to that, all signs here, they are negative. Here, they are positive. Here, they are negative. Okay? It means what's happening here, it is the inverse of that. Positive, negative. Now, let's look at the second quad. On the second quad, 1, it is positive, okay? And of which we are having a physical component going up. And all forces going up, they are positive, or the sign of going up, it is positive. Okay, now the inverse of that, you are having now a sign going down, it is negative. But you are having negative, you are having positive, the opposite of it, it is what? It is negative. Now you are having negative, all forces going towards your west, they are negative. Then this side, all forces going towards the east, they are what? Positive, negative. Now this, it is the inverse, the opposite of that. It means what's happening on the third quad, it's exactly the same as what's happening to the second quad. Now, in short, I'm simply saying whether we are rotating anti-clockwise or clockwise, the forces will be, or rather the angles would be the same, but in an opposite what uh, direction, or sign there. Okay, that's what I simply mean in emphasizing as well the quadrants, that the opposite quadrants, they are equal and all that. In applying the coterminal principle, it is just that emphasis. Now, it means when we are rotating anti-clockwise and rotating clockwise, it means we can therefore be able to convert negative forces to be positive forces. For instance, if we are having sine theta and the theta there, it is negative, we can then convert it to being what? Positive. It means we can have negative sine theta. We've converted this to being positive. There it is. It is positive. Okay. Now, if we are having cos negative theta, we can convert it. It can be cos theta. The angle there, it is what? It is positive. Okay. Now, if we are having tan negative angle equals to negative tan multiplied by positive angle. We can then convert negative angles to being positive. Okay, if that's the case, the core terminal principle, if it is so, we can then convert negative to be, as well as they are reciprocal, or as well as their inverses. Vice versa, it is true. Cosec negative angle, we can convert it to be positive. It will be negative cosec multiplied by positive angle. Then sec, open bracket, negative angle, we can convert it to be a positive. It will be sec positive angle. Cot, it will be negative cot positive angle. We can therefore we can do what? Convert the negative angles to be positive. Now, let us then look at the negative angle identities. But I've already touched on them, or rather, that which we did here, it is called the negative angle identities. Okay, it is called the negative angle identities. It is called the negative angles identities. Okay, it is called negative angles identities. All right, that's what they are called. Now, before we can do any application there, let us then look at the reduction formulas. Let us look at the reduction formulas combined with the negative identity. negative angle identities. Let's look at the formulas there. Let's look at the formulas. Let's look at the formulas. Hopefully I'll be able to write nicely, you know. Let us look at your formulas, your identities, combined with what? With your negative angle identities. Now, we are having sine 180 minus theta equals to. Now, this occurs on the second quad, 180 minus. Then we are having sine being positive. Then we are having cos theta. We are having cos 180 minus theta equals to negative cos theta. It means this occurs on what? On the second quad. On the second quad. Then the third one, it will be tan 180 degrees minus theta equals to negative tan theta. Can you see that here? Here we've applied, it's negative there. Here we've applied the negative angle. Negative angle. We've applied the negative. Remember, it is cos. It means the angle here, it is negative. The coefficient of this angle, it is negative. But when we apply the negative angle identities, we are then able to convert the negative angle to being what? Positive. There it is. Can you see that? That's what we mean by that. Then on the third quad, we are having sine 180 plus. But we know that on the third quad, only tan, it's positive. Then with the combination of the negative, it will be sine theta. The angle, it is positive. Then cos 180 plus theta. The fact that it is negative on the third quad, then it will be negative cos theta. Now the angle there, it is positive. Then tan, only tan theta, it is positive. It is tan 180 plus theta, then equals to tan positive. That's what we have. Now, as well as they are reciprocal, that's how they work. As well as they are reciprocal, including the fourth quadrant, we are having sine 360 degrees minus. But the fact that it is cos, that it is positive on the fourth quadrant, then it will be negative sine theta. It is the combination. Here you can tell we are having the combination of negative angle identities here. Okay. Working with positive, converting negative angle to being positive. Then we are having cos 360 minus theta. Then it will be positive because cos on the fourth quad, it is positive. Then on the tan, 360 degrees minus theta, it is equals to negative tan positive angle there. Now, those are the formulas, including their reciprocal, it will be exactly the same. Now, those are your identities, good people. We are done reminding you of your identities. We are done of reminding you of all of the identities that we've looked on, the square or the Pythagoras identities. I mean, we are done. The reduction as well, we touched on it. Then we can now do the application. This was the continuity of the reminder of things that you are supposed to be knowing. Then from here we will then do the application. Thank you, good people.